I welcome each and everyone. First of all, I welcome the person with full of spiritual, the Holiness Swamiji, 20th Pontiff, Mailam Bammupuradinam, and who is the chairman of our college. I welcome our Swamiji. Next, I welcome the man with full of energy, our college secretary, Captain Sivadru Raju Kumar Rajendran. Sir, welcome, sir. Next, I extended my welcome to our college principal, Dr. S. Tirunavukarasu, sir. Sir, welcome, sir. Next, I heartily welcome our resource person, Dr. Bhuneshwari ma'am from Government Arts and Science College, Thiruvanenallur. Ma'am, welcome, ma'am. Next, I welcome the heads of both CS and CA department of SSBS Arts and Science College, Mailam, and various staff who are working in and around world, who are participating with the YouTube and Zoom link. I welcome all the participants once again. I welcome with my heart. Welcome you all. Thank you.
Thank you, sir. Next, it's time to know about our chief guest, today's chief guest. Today's chief guest is Dr. C. Bhuneshwari Madam, Assistant Professor, Government Arts and Science College, Thiruvanenallur. She has finished MCA and PhD in Annamalai University, Chidambaram. She has more than 15 years of teaching experience. Her area of interest includes image processing and data mining. She had published 20 international journals and one national journal in various fields in computer science. She had received the Best Women Faculty Award in the year 2020. She has also guided 10 MCA students and 30 MSc Computer Science students in their academics. She had also published the book chapter in IoT, Internet of Things. The chapter name is The Current Trends in Connected World on 2018. With this introduction, I welcome our chief guest, ma'am, to take over the session. Ma'am, please, ma'am.
Okay. Good morning to all. First and foremostly, I thank the management for given me the opportunity to share my expertise in this national conference. I wholeheartedly thank Swamiji, Secretary Sir, Principal Sir, and HOD Ma'am, especially Muthulakshmi Ma'am, for giving me an opportunity to share my views of image processing in this national conference. We shall move into the session now. First and foremostly, all might have heard about the term image processing. Image, this word plays a vital role each in all part of the life. So, without image, an image worth 1,000 words. This itself explains how much important an image is. So here I am going to present to you the basic concept. As a technology person, what are the basic concepts in the image processing and how we are going about it. Okay, this first slide shows the different images. So here, first we have our thing, that is two images where we have seen the difference in the clarity. The first image shows somewhat clarified thing, that is we have a brightness of the thing, and then here. So first and foremostly they started with the black and white images only. So I have posted the black and white images in the first picture. And then if we go over here, this is the photo montage of 16 photos. We have clubbed 16 photos here. You can see the Statue of Liberty over here, and the boat, a person is traveling here, and a building, and clouds, and water, and many things that are moving over here. So we see as an image, it is just a single image. But if you see, if we have done with the 16 photos, and they are digitally manipulated to give the impression that it is an original image. And then Here, this tourist person is standing on the top and they are seeing it. So it is this image has been circulated, but actually this is a photoshopped one. He is not standing with the aeroplane. You can see aeroplane is flying low, then the person is standing high. It is a photoshopped image. Similarly, if we see over this image, left side image, you can see the smokes coming over here. So here in the first image, we have increased the contrast and the smoke cloud has also been an increase. And in the left side, we have a clear thing of smoke coming out. But real photograph is the left side image, which shows the smoke coming out in a disturbed way. But this is being processed, which gives the things. And here also, in the hand, we are punching a sponge. This sponge is dropping out the water and the materials that are present in it. All these things are also manipulated images. So now I think you can get a small idea of what an image processing is. Image means photo, processing means whatever we are doing to make that image as an effective one, or to make the changes in the image we are doing, that is known as image processing. Okay. I'm continuing with the images itself. Here you can see the MRI image of the photo taken by the medical persons, and this is a synthetic image of the Death Valley. This is actually the place, but if we see over there, it is actually a image that is synthetic, that is formed in a mm, uh, formed by us, but it shows as if it is an original image. And here the output image of a vehicle tracking. If we go with the vehicle tracking, we have two things. Two persons are being moving in the cycle, and we are tracking over the thing. And this is also an image what we are seeing over here. Okay, so image we have seen. We know very well that computer understand only zeros and ones. The basic colors, what the three basic colors are red, green, and blue, and the range of the colors differs from 0 to 256 values. So all the colors ranges between 0 to 256 with different intensities. That is, if we move the blue, first red, if we move from 0 to 256, its value will be different. And if we combine with the green, then its value will be different. And with the blue, the value will be different. So color image means, what it does means, it includes the color information for each and every pixel. Pixel, what is meant by pixel means, it is a pictorial thing, that is whatever we see is an image, but the image when it is stored in the computer, it stores as a value. That value is known as a pixel. This value is nothing but the row and the column that contradict at a point. That point value is called as a pixel. So for visually, we see the different samples that are coordinated to give the color spaces. So color image representation. Color image, all the things will be stored in the raster map. In the image processing, we have two types, that is raster mapping and random mapping. In the raster mapping, it is stored in the two-dimensional array of integer in triplets. Triplets means in threes. Threes, we say it as triplets. And for each and every bit, it stores a 8-bit per pixel sample, and we have an application of more sample if we get a single image. For a single image, the pixel value will be in thousands and lakhs. And this is an example. We have an image that has 256 colors. So 256 colors means RGB colors, in which what I have explained earlier. RGB colors. This is the picture of the cat. Then the second picture shows the picture which is reduced to 256 colors in the RGB color space. RGB, it represents the red, green, and blue color space. Okay. So what is a computer graphic? As we see, It is if we give a syntax, the computer graphics or the program, it processes the things and we get the synthetic images. And we have other thing in image processing, that is our pattern recognition. Pattern recognition, we have different objects. If we give into the algorithm of the pattern recognition, it will classify the object. What does means? We have a set of fruits. That means we have apple, we have oranges, we have grapes, etc. So what we do is, with the help of the artificial intelligence algorithm, we will be writing the algorithm and saying that the things that are in round shape and that are in orange in color will be classified as oranges, and the things that are in apple, that is red color, can be classified as apple, and green color or black color can be classified as grapes. So this pattern recognition, what it does means, it depending on the depending on the algorithm what we give, it differentiates or classifies the object and gives it in a neat way. So this is known as a pattern recognition, which is a wide topic in our image processing. Okay, in pattern recognition, we have different types. One is our voice recognition. The first and for the human brain cannot be competed with any robots or anything, because we do all our things with the help of our brain itself. So we are just, what we are doing is, we are just writing the coding to recognize the voice. If I'm speaking means, the system will be able to recognize that I am the one who is speaking. That is known as the voice recognition. Speech recognition. Speech means we use different languages. If I speak in an English, my slang will be different, and in Tamil means it will be different, and in Hindi means it will be different. So the speech recognition, or with different peoples who speak different languages, we can also recognize with the help of the pattern recognition. And next thing is our face recognition, which we are very familiar with. All the things, that is all the Aadhaar card, what we are going, or all the bank details in the registration departments, we go with our face recognition. Okay, then iris recognition. No person in the world has the same iris, that is our eye, inner part of our eye. So iris recognition is also a part of our pattern recognition. Then character recognition. It means whatever we write, the handwriting. With the help of the handwriting, we will be able to know who has written this. So this is our character recognition. And palm recognition. The fingerprints of the individual persons, and the palm means the center part of our hand is known as a palm, and that palm recognition is also a subdivision of our pattern recognition. And our fingerprint, we all know what we are doing with our ATM machine or with any other authentical information, we go with our fingerprints. And also vein recognition is also possible with our pattern recognition. So in the pattern recognition, we have this most number of area, and researchers are going on in an enormous way in all these fields. Okay. We get an image processing. What is an image processing? We are giving as a raw image. The image will be processed and we get a processed image. This is the flow of the diagram. But what do you mean by a raw image? The image, whatever we capture, is not in a complete clear format. It has surely it has many errors or the disturbances in it. We can see while doing with the Photoshop, you will be removing all the marks in the photos, all the marks in the faces and all the other things. Okay, the raw image means whatever we just capture is known as the raw image. In the technical term, these raw images must be free from the noises. What we say as the disturbances is noises. Noises means unwanted pixels or unwanted data, whatever we have in our thing is known as your noises. So we need to find the suitable algorithm to remove the noises. Well-known noises. One of the noises, pepper and salt noise. That means small grains it appears, and those small grains we say it as a pepper and salt noises. Okay, so in here in the raw image will be filtering out all the things, and then whatever we need to process, that is we can increase the contrast or decrease the contrast, or we can increase the sharpness or decrease the sharpness, or we can blend the images, or we can join the images. Whatever we do, all those things are known as your image processing. And finally, what you need as an output is known as our processed image. So, in a single word, what we say, image processing means the raw image is processed by different algorithms and we get a processed image. That's it. It is known as your image processing. Okay. What are the different areas in the image processing? We have different number of areas in the image processing. So if you see over here, we have an image enhancement. Image enhancement can be done. Image enhancement means we are upgrading that things. So in what way you can upgrade means you can upgrade the brightness, you can upgrade the contrast, you can reduce the noise, you can do with the edge enhancement and zoom. Okay, brightness control, you all know what we do in our remote control, the same thing. That is our brightness control. And contrast enhancement, that is our color enhancement, we can also go with it. And noise reduction means whatever we noises, what I have said earlier. Here, if you see this image, it has the noisy images. That is, we have a dot over the whole images. And next image shows the noiseless, that is noise-free image. You don't have any dots over it. This is known as our noise reduction. Okay, then edge enhancement. What is this edge enhancement? Is it necessary? Yes, of course. We are taking a picture. If we want to crop the picture in the portion which we want alone, then we go with cropping node. In the same way, the edges of the images has to be in a uniform manner, and that is known as our edge enhancement. Then zooming. Zooming means we are viewing it in a clear thing. We can make it as a large, or we can reduce the size. That is known as our zoom. And next areas, in the image enhancement itself, many things, and other areas of image processing are image restoration, image segmentation, image registration, watermarking, inpainting, compression, fusion, retrieval, super resolution, visual cryptography, etc., etc., etc. So we have this many areas in our image processing. So image restoration, whatever we have an image, that image should be restored in a neat way. That is known as image restoration. Segmentation. Segmentation part where we go means, in the case of medical imaging, we have our MRI and RCT scans. The scan, after scanning the images, the part that is being affected must be clearly seen by the doctors. So what we do is we go for image segmentation. Segmenting means we are dividing the image into smaller pieces. Okay, and then image registration. Whatever image we get, we are getting it registered, and all the processing are done with it. Watermarking. We have heard about the term watermarking. That is, copyright the image must not be used with anybody. So we are watermarking the things. Then in painting. In painting means we are in the same image, we are going with the paint of the another image. That is known as in painting. And image compression, we are reducing the size of the images. That is known as our image compression. Fusion, that means we are joining with the more two or more images. That That is mean by fusing. Retrieval. Whatever image you have, we are getting the correct image. What we want, that image is being retrieved means then it is called as image retrieval. Super resolution. Super resolution means this resolution, the image resolution must be thing that is in a good resolution, which gives a clear image. So we go for a super resolution. And visual cryptography. Visual cryptography defines that uh, that is, the cryptography means we are hiding the image and we are showing this hidden image must be can be hidden with the help of the images too. The images can also be hidden or the documents can also be hidden. This type of thing is called as visual cryptography. Okay. So these are all areas, whatever I'm discussing, these are all the areas of image processing. Okay. So this is an image of the eye. Before, if we go into an image processing area, first what we have to know is the image of our eye, what it does. Our image has the following things. We have our lens and all the things, how our images are focused and how it's sent to brain, and this is the small thing. So using the same technology only, the camera is being used. So the camera is being designed using this same technology. And here is the image where I have a three options. Okay, Eiffel Tower, it is little bright and this is cloudy, this is fully dark. What I do is I have merged all these things and given a new thing. That is, it is with the work of the image processing. This is known as our image processing. So discrete image, what I said earlier, discrete function means a function which has x and y value, that is f of x and y value. If you manipulate the pixels in x and y, then we call it as a discrete function. Okay, this is an example of the values of that particular image. In this image, we have the x values and the y values that are being printed in the represented in the matrix format. Okay, then what is image filtering? We are modifying the pixel in the image. That is, we are changing some images. Thing. We are filtering out the we are filtering and taking only the possible values or needed values. So that is known as image filtering. So here we have our thing. We can also modify the pixel depending on the neighboring pixel. So here this is a local image. If the local image has the values 10, 5, 3, then 4, 5, 1 and 1, 1, 7. So if we get an average, overall average of this, the value can be modified as 7. So the images cannot be modified in a so the images can be modified but without many changes. That is known as our modification or image filtration. Okay, then we have our linear function. Linear function, that means we can replace each pixel by the combination of the neighboring pixels. That means a single pixel, if we have in the previous example, we have said that we have our different values, that is 10, 5, 3 and etc. And these different values can be modified into 7. This values is known as our image filtration. Then is our linear function. Linear means, we all know, linear means it means line. It is a combination of the neighbors. That means the x values and y values and different values can be combined, and this values gives our linear function. What we do is we are replacing each pixel by the linear combination of the values. This linear combination is known as our convolution kernel. That means we are combining or replacing different pixels in different combination. That is known as our convolution kernel. So here is an image where it shows the local area data. We have 10, 5, 3, 4, 5, 1, 1 and 1 and 1. Okay, what we do is we are creating a convolution kernel. So for kernel, what it does means it takes all the values, it does some operations, that is multiplication, it combines, uh, add, subtract, multiply, and do all the things. And after the processing, the intermediate value of the kernel will be like this. And after the modified image, the value 7 is being obtained, and that 7 will be replaced by the value 5. That's the thing. So to get a better image, we just see only the images and we are working on the images. But internally, what the system does is it calculates all these values, and all these values are being displayed or modified by the image data. Okay, and this is blurring image. So what is a blurring image? We have seen this, the thing is very blurred and all. So what it does means we have an original image like this. Images, its pixels are like this. And if we set the coefficient and pixel offset, your blurred image can be filtered in both the dimension, that is x and y dimension, and we get the images like this, so that the pixel values can be in a uniform thing, that the manipulation of the things can be easy. Okay, and this is a sharpening example. Sharpening, we have an original image. That original image need to be sharpened, means we are sharpening, and the values and the output of the values will be a sharpened one. Okay, spatial resolution and coloring. So this is our original image what I take. So these two kids are standing over there, and if we split into red, green, and blue, these values will be like this. That is, the images will be like this. After combination of these three values, that is our red, green, and blue, we get the original image of this. This is the thing what is being happened when we are processing the images. The system, what it does, it gets the value of the red, it gets the value of the green, and it gets the value of the blue. After manipulating all these three values, we get the original values, what we are doing, what we are getting as an original image. Okay. So who discovered it? What was this done? What was the color fundamentals? Or if we know all these things only, we can be clear with the color crossing concepts and all. In the year 1966, Isaac Newton discovered if sunlight is passed through a glass of prism, it gets deviated into 7 different colors. So the colors beyond the things called as ultraviolet, and above the things is known as your infrared. So the color spectrum will have the Vibgyor color: violet, indigo, blue, yellow, orange, red. Vibgyor color. This Vibgyor colors are the colors by which all the images are being colored. Okay, so this is the broad branch spectrum: violet, blue, green, yellow, orange, and red. So if you, what is the combination of all colors means white. Okay, if we combine all the colors, it will be white. If it is no color means it is black. So 0 lies in black, and white, 1 lies in white. Okay, if you have a thing, basically what we see in our eyes, what we think in our mind, everything is the reflection of the natural images what we do. Okay, then electromagnetic spectrum, we need to know a little bit of physics along with our image processing, then only the speed, that wavelength, all those things can be known into things. Electromagnetic wavelength means it differs from 400 to 700 nanometer. Okay, the light source, when it is being thing, that is monochromatic light, and dichromatic or trichromatic, that means mono means single colored is known as achromatic light source. If you have more colors, that colors is given by chromatic light source, and we have different things, that is attributes over it. One is radiance. Radiance means total amount of energy flow from light to the sources, which is measured in watts. This is meant by radiance. That means the amount of energy which is flowing from the light. Whatever energy that flows from the light, that is known as our radiance. Luminance means amount of energy received by the observer. At the other end, whatever we are receiving, that is known as a luminance. Brightness means intensity, or how bright it is, that is known as the intensity. So this is the color fundamentals. We go with it. So color we have a wide spectrum. The wavelength, depending on the wavelength of the colors, we go with it. One is our visible spectrum, and the beyond it is ultraviolet UV rays, and the other end is our infrared rays. If you want to see our UV rays or ultraviolet rays, it's not possible with our normal eyes. We go only with our added technology, added specs is only we can view our ultraviolet rays or our infrared rays. So this visible spectrum ranges from 400 to 700 wavelength in nanometer. Okay. So the color of the things, the color depend upon the wavelength composition. That is, we have our narrow bandwidth, or you can have all the things, all the light with equal energy. If all the colors is being shared means, as I said earlier, it will be in white color. Okay. So this is our primary colors and our secondary colors. So primary colors, red, blue, and green. If we combine, we get all the other additive primaries or subtractive primaries. Whatever we want, we can get the other colors. With the help of this only three colors with a range of 0 to 256, we are getting all the colors. Whatever we see or whatever we wear or whatever we enjoy at it, all this is a combination of the colors only. Okay. The primary colors RGB, that is red, green, and blue, and in the subtractive colors we say as CMY. What is meant by CMY means cyan, magenta, and yellow. Cyan color, that will be like a green and blue combined color, that is known as cyan color, magenta color, and yellow color pigments. So RGB, if we combine all this thing, we get white. CMY, that is subtracted colors, we get black. Okay. So how do we represent these three colors means, as our human retina is having different cones in our eyes, this cones will be sending the signal to our brain to say this is the color that you are seeing. The absorption response will be, that is the peak response is 450 nanometer for blue, 550 nanometer for green, and 620 nanometer for yellow to green. These are the values, and the color sensation also depend on the different values, that is sigma of 1x. These are all the representation of the different color spectrums what we actually go. So initially, that means our perceived color will be alpha 1 of x1 will be equal to alpha 2 of alpha 1 of x2. Okay. Color characterization. So we have been till now we have been speaking about colors. So what are the characters that are available in the colors? Hue, saturation, brightness, chromaticity, tristimulus. So these are the things: hue, saturation, and brightness. These are the three major characteristics. What is meant by hue? Hue means the dominant color with the dominant wavelength of mixture of light waves. That means how much of dominant color is seen in an image with the dominant wavelength, that is known as our hue. Saturation means it is the purity or the amount of light mixed with the hue. That means how much of white color you are saturating with your hue is known as your saturation. Then brightness means gives the intensity, how well it goes, that is known as our intensity. This hue and saturation together is known as our chromaticity, and the amount of your red, green, and blue is known as tristimulus. Since it is three colors, we go for the word tri, T-R-I. Tri means tree. Stimulus. At the same time, how we are combining this red color, green color, and that blue color. That is known as a tri-stimulus. Okay. So these are the three characteristics, that is hue, saturation, and brightness. Okay, this is the graph. It shows the different colors, that is green, yellow, and pink, and blue, and all. So this is the various spectral angles or spectral energy where we go with the different values and the wavelengths and nanometers, etc. So this diagram is a chromaticity diagram. Okay. Then is our color models. So color models RGB, red, green, and blue. CM white, CM magenta, and yellow, and other type of thing is CMYK. All these things, this values, that is K, all the other things, all the colors only. So we are representing it with one symbol, one letters. So if you want to print with the model color printing, we go with the CMK color or CMYK color, or with the HSK model. HSK model shows how the humans are interfacing with the thing, that is known as the HMK model, and HSI model is also available over there. RGB color. It is a Cartesian coordinate. If you see, it is C. We have a different blue, red, and green colors. It is a combination of these three colors, red, green, blue. The first dimension, what it gives is 0, 0, 1. For blue, it is 0, 0, 1. For red, it is 1, 0, 0. And for green, it is 0, 1. Sorry, 0, 1, 0. Okay. So if we combine these colors, we get with the cyan, magenta, and yellow. This is known as our CMY colors. CMY, cyan, magenta, and yellow color. So the portion that is above this will be black color. This thing will be black, and the portion which are covering between these will be white colors. And here is this gray scale. We know this word. We have been familiar with this only. In the word also, if we go with the images, and if we want to change the images, means we have an option of black and white or grayscale or color images. If we go with the grayscale images, it will be clear. Grayscale is a combination of the white and the black color. This white and black color will give our grayscale images. Okay. Here, the what we have seen as a cube. So that same cube, I have put it as a colored one. Okay, these are the colors I told. Here it will be green, here it will be blue, here it will be yellow. So the same colors. What I have given as an just in lines, I have given a different images. So R, that is red, it is 8-bit, green is an 8-bit, blue is an 8-bit. So totally 24-bit. Okay. So the color which you get is over here is what, how many number of colors we are getting is 1677216 colors are possible with these things. So hidden face of the cube. So what the hidden face, the three hidden face will be showed, will have the colors like this. If the red is 0, it will be like this. If the green is 0, it will be like this. If the blue is 0, it will be like this. Okay. So as I said earlier, your red, green, and your blue, these combine together in the color monitor, and this color monitor will project us with the RGB colors. So we have seen all these colors in our color pamphlet in whatever application we go with. That is, we have 216 colors common in our operating system. So with so the values of the colors start from 00000, and we end with the FFFFF values. So here is an sample of all the colors that is being shown. Okay. RGB safe colors. RGB cube is again divided into different things, where we have different 6 power 3 means you have common 2 and 6 colors. This 8-bit of values is represented by 256 colors, and the remaining things are left in our operating system. So in the hexadecimal, if you go with that, the starting value is 00, and the color equivalence we give us 33, 63, 99, and CC up to FF we are getting. And in the same way, in the decimal, we represented it as 0 to 255. Okay. Uh, then CMY, that is as I have previously explained, C means cyan, M means magenta, Y means yellow, K means black color. To represent a black color, we have this color. So CMY, magenta, cyan, magenta, and yellow, which combines. So how it is obtained means it is a subtractive value of the things, RGB colors. If it is a additive value, we say it is an RGB. If it is a subtractive value, we tell it as cyan, magenta, yellow colors. So the whole value is represented as 1. From the 1, we are separating our red color, we get the cyan color. If we subtract with the green color, we get the magenta color. And if we subtract the black color, we get the yellow color. So this thing will be an example of how this cube is an example of how CMY colors are being done. So this CMY colors, as I have explained with your RGB, here also we have our cyan, magenta, and yellow colors, and the range of this. If the thing is goes with this, means it is a blue color, and if it is goes here means a cyan color. If we have a green, means it will be lying here. Yellow will be here. Red color will be in this area, and magenta color will be in this area. Okay. Then is another type is HSI. HSI model, it says it is a hue, saturation, and intensity. Hue, what is the dominant colors that are present, that is known as our hue. And saturation, that means pure, how much pure the color is, that is known as our saturation. It is inversely proportional to our white light. That is, if we get a white light, the inverse of it, 1 by that light will give our saturation value, and the intensity shows the brightness. Okay, this HSI model is a color carrying information. So this is the relationship between RGB and HSI color models. So here we have a different, in the cuboid, in the cube, we have our values or the colors that are being, different colors that are being assigned to it. That is, white color will lie over here and the black color over this end. And this end you have a blue color, here red color, here green color, yellow, magenta, cyan. And the same way, what I have said is HSI model means it is one inverse, that is 1 by RGB. You are minusing, that is you are subtracting the colors. So the subtracted colors will be represented as, if we tilt the thing, if we tilt the cube, what it represents as a diamond shaped one, and the center of this will be appearing there, and this center of the thing can be used for your HSI color models. Okay. And here shows the manipulation of HSI components, that is hue, saturation, and intensity. If I go with our RGB colors, red, green, and blue, your hue will be like this, and your saturation thing will be like this, your intensity will be like this. And the same way, your hue can be, that is the remaining part. Here you can see as a circle, the circle intersecting part alone is taken over here. And the same way, here also it's taken, and here also it is taken. If you take it as an RGB image, it will be resulting in the images like this. Okay, so far we have seen different images, colors, and different things. We feel very difficult to send a single file Word document also in a thing. But if we go with the compression, means it is a great technique that will reduces the size of the digital image. If we are using with our digital image, it is part and parcel that we have to use our compression technique. Okay, so what is how is compression possible? What it is doing means, what it does means, redundancy, whatever redundancy or the repeatedness that is appearing in the image, it gets compressed. The redundancy in the data image and the data video data are being compressed, and only the images, that is the essential parts, are being traveled from one end to the another end. In the digital audio, we have a spatial redundancy. That means neighboring images we are having, and those neighboring images will be sent to the things. These are the this is the part of the compression. We just know the image is being compressed, or we are compressing the file like that we are saying. But what the technology behind this is we are reducing the redundancy of the digital image, and we also have our neighboring sample values. Neighboring sample values are correlated. That means the values I have already explained that these values are done in our pixels, and pixel values we are being correlating. Correlating means relating the values. If both the values are nearly equal, means we can average the values so that we can get the uh, good images like that. Okay, compression. It's of two types of. There are two types of compression. One is lossy compression. Another one is lossless compression. What is meant by lossless compression means the information is not being lost at all. That is known as lossless compression. Original data, whatever we exactly recover, whatever we get, that will be reflected in our compressed data, and our compression ratio will also be lower. So this is one of the important concept which you need to know regarding the compression technique. This lossless compression is a best method. And if we go for the lossy compression, some of the information may be lost, and also we can lose the information in an we can there is a part that is a part of the information get reduced, or it gets deleted. And also we have a higher compression ratio when compared to the lossless compression. So if we compare lossless and lossy compression, lossless is a better one than to go with it. Okay, what is done in our lossy compression means we have our original image. Okay, this original image, what it does means we are doing the transformation. The transformation, the word alone, whatever we do, we have different technologies and the algorithms with it. Those technologies and algorithms need to be implemented in the original images that will go to the next stage. Okay, so the different technologies are the algorithm. What we are going on: Fourier transform, wavelet, rigidlet, curvelet controller, bandlet. So these are the different types of transformation what we perform. So after this, the image will be transformed to what it will be transformed to reduce the correlation between the pixels. How we are transforming means we can have uniform, adaptive, or non-uniform, or entropy coded in the case of scalar vector. And with this methods, you are reducing the things. After reducing, you will get the no interpixel redundancies will be available over there, and a quantization process is being performed. This quantization process, what it does is, it will not be reversible. It will not get into a reverse thing. Whatever you have done, but that it will be processing. So by using the scalar and the vector product, that is vector product, you can have your Lindy Buzogray form, tree structured, or Terlis coded. These things, after that, we will have a source coding. So source coding, what is the source coding means? We have different method: Huffman coding, arithmetic coding, Pasimal coding, run length coding, etc. These are the different methods. These are the different source coding which we go about it, and this will be the best streams. No coding redundancy reversible. That means all the images will be reduced to the bits, and this bit stream will be transferred. If you unzip the thing and get it, you will get the images. Okay. So these are the metrics, quality metrics, what we have to see while sending or getting the images. We have seen that what is meant by lossy compression, and how what is the methodology that is used to be in the lossy compression. So we have already mentioned that the lossy compression means some images may be lost. So those images, what we have to do is we have to measure the performance of the image compression. The performance of the image compression can be measured by the different measures such as root mean square error method, or mean square error, or PSNR value. Mostly we go with PSNR. PSNR is very important regarding the image processing techniques. Peak signal to noise ratio, or we have our compression ratio overall. So these are the different quality metrics go for our compression performance. Okay, so this is about the compression performance. Then we go for the image editing. Editing means we are doing some changes with the image. That is known as our image editing. So image editing, we have our pictures or the pixels. And this pixels, if you change our color, brightness or any other information regarding it, that is known as our image editing. So here, this is an histogram. This histogram, what it does means, we are creating the images and this images will plot the values for this. If you see this sunflower histogram value is represented like this only. So the backward, that is grayscale, denotes the apart from the sunflower, we have suppose one plants behind it, no? Those values are represented as gray, and all the red values are gives the histogram of the sunflower. Okay, so we can also change the depth of the colors. Depth of the colors. It can be common color depth. It is 2460 or 256 or 536 or and 16.7 million colors, up to 16.7 million colors. It's possible for us to generate the things. Grayscale conversion, why we are using is you are reducing the file size dramatically from the original size, so that it can be used in the it can be passed or it can be used for all the manipulations. Okay, and also how we can enhance the image. Enhance means you can if you manner by sharpening images means blur images can be sharpened, and also selecting and merging the images. That means we can select or merge the images. Select means we are selecting the particular images. Merging means we are joining more than one images. Then the images, as the word denotes, we are cutting it into the cake. If we take the cake, we are slicing the cake. That means we are cutting the cake the, with, the, with a knife or something. Then it is called as a slicing of the images. Okay. Then color depths also we are seeing, and here is an example of the uncropped images from our camera. That is cropping and uncropping means we all have seen. Cropping means the selected part what we get, that is known as our cropping image, and the whole part in the previous image we have seen that it is a full image. After uncropping, we get the cropped image. That is, we want particularly the flower to be seen means that can also be done. Okay, and if we go with the image editing, we have that is reduce the noise, and we need to remove the unwanted elements, and we have to select the colors, and also we can select the image orientation, etc. Noise reduction, as I have already said, this noise reduction does means the unwanted dots or pixels, whatever that is appearing in the image editing, that is known as our that need to be removed, and that reduction process is known as our noise reduction. And the removal of unwanted things, that is clone, or if we want to remove some branch of the trees, or that's something that is known as removal of unwanted things. Uh, if we have an image over there and we want to do some changes, those changes can be done with the removal or removal of the elements. Selective color changes. We have different selective color changes. One is image orientation. Orientation of the images. It is done with the altering. That is, we can be rotating it in different direction or different angle. That is known as our image orientation. And perspective control and distortion. That is, the shape of the images can also be transformed from one way to another way. And also we can edit the image by the presence of our lens corrections. Lens correction, we are seeing that while going for the spectacle while we go for a spectacle according to our eyes distance, that is, it is whether it's a long sight or it is with a long sight or short sight, they will be correcting the lenses. Similarly, the images can also be corrected with the help of the lens correction. This are the different methods with the image editing. With this short period of time, I have covered the overall view of what is meant by image processing and what are the different techniques that are being used, and how an image can be represented. We all know what is an image and everything and all, but the technological part of view has been given by me in this time. Any queries, views, we can go with it.
We move on to the next session. That is, now I would like to call Mr. G. Gopinath sir, Assistant Professor, Department of Computer Application, for vote of thanks. Sir.
Good morning, one and all. It's my privilege to give vote of thanks to the dignitaries gathered here. First of all, I would like to thank our Holiness of Swamiji, 20th Pontiff, Chief Patron, Chairman of our college, for his blessings, makes this section grand success. Thank you, Swamiji. Next, I would like to extend my thanks to our respected Secretary Sir, Captain Raju Kumar Rajendran, for his motivation and encouraging. It makes us to doing such kind of national and international level webinars. Thank you. Thank you, sir. Next, I would like to thank our respected principal, sir. His encourage and support make this session grand success. Thank you, sir. Next, I would like to thank our chief guest, Dr. C. Bhuvneshwari, Assistant Professor, for his wonderful session and explanation about the image processing. Definitely, ma'am, it will helpful for us to understand the image processing process in a different perspective. Definitely, it will help to research-oriented students. Thank you, ma'am. Thank you very much. Then, next I will thank HODs of various department, then staff members, then other technical staffs. Finally, I would like to thank participants and students for his active participation and patient listening. Once again, thank you one and all. Thank you.
Thank you, sir. Thank you, one and all. Thank you. Thank you, ma'am.